Good afternoon. My name is Adrian, and this is my partner, Ilan. We're both on the Belmont Hill School Drones team, as well as the school's Sustainability Club. When people think about climate change solutions, they usually think about solar panels, electric cars, and wind turbines. Not that these don't work, but they're proven technologies and important ones.
But today we want to introduce a different type of climate tool, one that, when thinking about sustainability, might not come to mind at first: drones. Drones have immense potential to do good for many different industries that are trying to combat climate change by serving as an alternative to different tools like helicopters and trucks by emitting a lot less carbon.
Through the Sustainability Club, we've had the chance to see environmental action up close. We visited the Common Farm over there, a unique institution that uses sustainable agriculture across 18 acres of land.
We've also had weekly club presentations on emerging sustainable technology. Last month, I attended a youth climate advocacy event at the Massachusetts State House where we discussed different climate policies and talked about them with representatives.
On the drone side, we design, build, race, and market as part of the Drones in School competition. At some point, working in both of these spheres, we start to ask ourselves a simple question. What if the same engineering skills that we use in the design process could be applied to real-world problems?
When we say carbon emissions, we usually think of the obvious sources: power plants, factories, combustion engines. But a surprising share of operational carbon doesn't come from this. Actually, it doesn't come from generating power or producing food, but it comes from the tools we use to inspect, monitor, and manage these things. Here's what it looks like in practice. A study by Airpelago calculated that helicopter-based power line inspection uses up about 11.7 kilograms of carbon dioxide per kilometer. A battery-powered drone that does the same, only 15 grams. That's a 780 times fold reduction. That's huge. For a single utility company with about 22,000 kilometers of overhead power line, which isn't too much, isn't too excessive for a normal company, switching from helicopters to drones could save an immense amount of carbon, up to 258 tons per year, just from one company, just from one switch. And it's not only power lines. Helicopter surveys, tracking deforestation, trucks, fleets inspecting pipelines, field teams driving hundreds of miles to count wildlife. These aren't glamorous sources of carbon. They are real. They are quantifiable, and most importantly, they are preventable. That's the opportunity we're here to talk about today.
So drones can reduce carbon in 3 different ways. First is direct replacement. A drone survey emits a fraction of what a helicopter or truck fleet would, as seen with Ilan's statistics. Using the same coverage area, there are drastically lower emissions. A peer-reviewed study by the journal Patterns, based on 188 real drone flights, found that drone energy consumption per delivery can be up to 94% lower than conventional vehicle use. Secondly, reducing frequency. Because drones collect data at faster and far higher resolutions, you need fewer total deployments. One drone flight replaces what used to be multiple vehicle trips. Percepto, a company recently granted EPA approval for autonomous methane monitoring, reported that in a single 3-month-long deployment, their drones found over 130 potential emissions events, saving more than 1,000 fieldwork hours. And finally, prevention. A drone that catches a methane leak early, or maps a wildfire before it spreads, or detects deforestation as it starts, that drone is stopping carbon from ever entering the atmosphere in the first place. This saves both time and carbon emissions from future monitoring efforts.
All right, let's look at where this gets deployed practically. Environmental monitoring is the most direct application and the one where measurements will be the most quantifiable in the near future. Right now, conservation agencies and government departments rely on helicopter flights and vehicle fleets to track deforestation, map coastal erosion, count wildlife, and detect methane leaks. Let's talk methane. The numbers are staggering. Methane has over 28 times the warming potential of carbon dioxide over a 20-year period. A Stanford study of the Permian Basin, a basin in New Mexico, has found that over 9% of all methane produced in the region was leaking into the atmosphere. That's several times higher than the Environmental Protection Agency had estimated. Traditional detection, crews with handheld sensors, cost about $600 per facility visit, depending on case, but with up to 4 visits required per year. With over 30,000 oil and gas sites in that basin alone, costs can approach over $70 million per year. Drones, however, with the laser-based methane sensors, can screen the same infrastructure faster, cleaner, cheaper, and more efficiently. A monitoring drone with multispectral cameras and gas sensors can replace dozens of helicopter flight hours per year. The data is actually better, higher resolution, more frequent, and accessing terrain too steep or remote for ground crews to cover. It doesn't sacrifice capability. It's just introducing a new tool that happens to produce far less carbon.
Here's one more case study: precision agriculture. Drones equipped with multispectral cameras, as Ilan mentioned, can map crop health at a resolution impossible from the ground. And when farmers use this data, they can apply fertilizer and water only where the crops actually need them. And why does that matter for the climate? Because fertilizer overuse is one of the leading sources of nitrous oxide, a greenhouse gas that, according to the EPA, is 280 times more potent than CO2, pound for pound. Agricultural soil management is the single leading source of nitrous oxide emissions in the United States. And globally, human-caused nitrous oxide emissions have risen 40% over the past 4 decades, and this is driven largely by the synthetic fertilizer use. A systematic review published in the journal Drones found that precision drone spraying can reduce fertilizer consumption by up to 30% while maintaining or even improving crop yields, while application accuracy reaches around 90 to 95%. There's better data, less waste, and a smaller carbon footprint. Now, we'd be dishonest if we didn't acknowledge the limitations of this emerging technology. Drone battery life is currently capped at around 30 to 45 minutes per flight, and payload capacity is limited because you're not going to be able to replace a cargo helicopter. Regulatory frameworks such as the FAA restrictions also slow deployment in the US, as unmanned aircrafts are a safety risk if not handled properly.
But here's what actually matters. Every one of these constraints is trending in the right direction. Battery energy density has doubled over the last decade, and solid-state cells are on the horizon. Autonomous, drone-in-a-box systems like the ones Percepto already deploys eliminate the need for a pilot on site entirely. And the FAA has approved its first autonomous methane monitoring drones for compliance in 2025, signaling the regulation is catching up. The question now isn't whether drones are perfect today, because they're not. It's whether their drawbacks are improving, and that they are.
Think about what we've covered. A 780-fold reduction in emissions for power line inspections. Fertilizer use cut by 30%, reducing a greenhouse gas 280 times more potent than CO2. Methane leaks identified in days rather than months, preventing greenhouse gases that would otherwise silently accumulate. Here's the broader idea behind all of this. Solving climate change is not just a single breakthrough. It's not one invention that fixes everything by itself. It's a step-by-step process. And a big part of this process is by identifying solutions and changing how we think about the technology that we already have.
So what can you do with this? First, explore. Look into drone sustainability research. For example, Flash Forest, a Canadian company using heavy-lift drones to plant seeds, is working towards a goal of 1 billion seeds by 2028. That's something you can just simply look up on your computer and already have a big impact. Percepto, for example, also just received its first EPA-approved autonomous methane monitoring drone system, as I mentioned. And this isn't theoretical, it's happening right now with actual companies and actual case studies. Connect. Mass Audubon and the US Forest Service are already using aerial data for conservation. Reaching out is more accessible than you think. Pursue. If you're interested in STEM, consider a path combining engineering with environmental impact. That intersection is where some of the best work will occur over the next decade. Technology isn't something that happens to us. It's something we can shape. And the more people in this room see it that way, the closer we get towards having a greener future. Thank you.
Thank you.